Hi, so I just wanted to go over with you guys some of the polynomial operations that you started working on this week. So at the very beginning of the week, the first thing we did was the introduction of polynomials. So what a polynomial is, some of the vocabulary like terms and coefficients, degree. Okay, so all of that we went over, and then we started getting into some adding and subtracting. So I just noticed that looking at the Ed puzzle that you guys did on adding and subtracting, I figured it didn't hurt to go back through a couple things to make sure that I answered maybe some of the questions you guys had and clarify a couple things. That way, when you guys practice on your own, it makes a little bit more sense. So I wanted to do 2 of each type. So 2 adding, 2 subtracting, and I'll post the notes and everything too so you can go back and look at them. And feel free to work through these as we do, so that way you guys can kind of look at your own work. So in our first example here, we're going to be looking at addition, okay? And I know that it's addition because there is a plus sign between, okay? So that's always what I look for first. Okay, so I see it, there's a plus sign. So I'm adding this first polynomial, 2x squared minus 3x plus 5, to this other polynomial, x squared minus 4x plus 1. So when we're adding, all we're going to do is combine like terms. So in order to be a like term, you have to have the same variable with the same exponent. So if I look at this one here, 2x squared, and I look over here at this next one, this also has an x squared. Okay, so I know that those are like terms. They both have x's and they both have an exponent of 2. Just to make my life a little easier here, I'm going to draw in the 1 that's really in front of that x squared. Okay, but in math, a lot of times it's not written in. I'm just going to put it there to help me out. Now I just add 2x squared plus 1x squared. I'm just going to combine the coefficients. 2 plus 1 gives me 3. Then when I'm adding, I keep the variable and I keep the exponent the same. So it's staying in x squared. That doesn't change. Then I go to my next one. I've got a negative 3x plus a negative 4x. So this is where if I'm not comfortable with my negatives, I check myself in my calculator. Negative 3 plus negative 4, they're both negative, so I'm going to add them together and it becomes a negative 7x. Last but not least, I'm going to add my constants. So the ones that don't have x's, I've got a 5 and a 1. So 5 plus 1 gives me a 6. So it's a positive 6. I'm going to connect it with a plus sign. Just to go over a little bit of that vocabulary that we talked about in that first lesson, this polynomial has 3 terms or 3 parts. So this first part is this 3x squared. The second part is this 7x. The last part is the 6. The parts or the terms are always separated by pluses or minuses. Since there's 3 of them, we would call this a trinomial. Okay, and another thing that we talked about before is something called the degree. So degree is just the highest exponent or highest power. So for this trinomial, our highest exponent is 2, so it would be a second degree or a degree 2 polynomial. We're going to be talking a lot about those as we finish up this school year. Okay, so that's our first one. Second one here, now we've got b's. An example 2. Okay, so once again, we've got 2 polynomials. We have 16 minus 3b minus b squared. I see, there's a plus sign there, so we're adding. Then I have b to the 3rd power minus 4b squared plus 11. Okay, so I've got to be careful because there's a few different b's here. So first thing I notice as I'm looking through, that I have this b to the 3rd power. That's the highest exponent I have. It's also, as I look through, the only b that has the 3rd power. So that one I'm going to write first. I like to start with my highest exponents. That way my answer is written in standard form already and I don't have to rearrange anything. So then in my next one, if I look at my next highest exponent, I've got my squareds. I have this negative b squared and here I have negative 4b squared. I'm going to put in that negative 1 just to help me out. So I'm adding negative 1 plus negative 4. Well, they're both negative, so I'm going to add them together. I don't have to worry about changing signs. 1 plus 4 would give me 5, so that's going to give me negative 5. And I can put that right in my calculator if I'm not sure. So because we're adding, our variable and exponent stay the same. So those with the squareds stay squareds. Okay, then I keep looking. Oh, here is a negative 3b. That's my next highest exponent. And as I look, that's my only term that has just a b. So it's a negative, so I'm going to bring down that negative sign, and it connects to my polynomial. Last but not least here, I have my constants. I have 16 plus a positive 11. 16 plus 11 gives me 27. It's a positive 27, so I connect it with a plus sign. There's no other like terms here, so that's done. This is our answer. We can't simplify it any further. Now, as far as naming this goes, it might have a fancy name by terms, but anytime we get over 3 terms, we just kind of call them polynomials and call it a day. Okay, but this one, I can still say the degree. So degree, again, is the highest exponent. So in this case, our degree is 3. Okay, so that's addition. Subtraction is very similar. There's just one little thing that we've got to be careful with. Okay, so we're going to talk about 2 problems here with subtraction. So when we're subtracting, we have to be a little bit more careful with signs, and the order matters in subtraction problems, where I didn't have to worry about it too much in my addition. So in the Ed puzzle, they showed you when you're dealing with these parentheses, there's really ones out in front. Okay, and if I think about this one, and if I were to put a 1 out in front of this first set of parentheses and I were to distribute that, well, multiplying everything by 1 here is going to keep it the same. And that's what would happen in an addition problem. We'd be distributing positive 1s and nothing would change. What's different is when we're dealing with this subtraction here, really that's like having a negative 1 hanging out in front of that second parenthesis. So here, we're going to have to distribute a negative 1. This is going to change things. It changes our signs. So negative 1 times 4n squared becomes negative 4n squared. Negative 1 times a positive 1 is a negative 1. Once you distribute that negative 1 and those parentheses are gone in your subtraction problem, it then becomes a combining like terms problem, just like we did for addition. So these are essentially the same types of problems, just with an extra step. Okay, so I'm going to start with my n squared. So I have 3n squared, and over here I have a minus 4n squared. So 3 minus 4 leaves me with negative 1n squared. So when we're subtracting, same as addition, those exponents stay the same. Okay, I go to my next highest exponent. Here I have an n. So minus 4n. There's no other n's. So I'm just going to bring it down. Minus 4n. Last but not least, I have my constants, the ones without a variable. Positive 7 minus 1, or positive 7 plus negative 1, those mean the same thing. Well, 7 minus 1 leaves me a 6, and it's a positive 6, so I'm going to connect it with a plus sign. So here I have a trinomial again. It has 3 terms. You could write your answer like that, or a lot of times what's going to happen, they're not going to put in, if this is multiple choice, they won't write in that 1. This would be the same thing as negative n squared minus 4n plus 6. So these two mean exactly the same thing, just one has that 1 written in and the other doesn't. Okay, but both would get you the same answer. The last one, and I don't think this was in the Ed puzzle that I'm remembering right now in that video, but this is something that we've looked at this year. And it's the problems where they ask us to subtract something from something else. So in this case, we're subtracting this polynomial 5x squared minus 6x plus 1 from 2x squared minus 7x minus 8. What you might remember early on this year that we called this like a turnaround phrase, okay, or where we switched the order, okay? So you might remember us saying that. And all that means is that when you're subtracting from something, this second part, that second polynomial or second number, that's actually what goes first. And we've got to turn around this problem. Okay, so all I'm doing before I start actually subtracting is I'm just writing out my problem, okay? That way it's all set up for me. Now it looks just like the one we did up above. Okay, so I'm just going to switch colors here. Okay, so my first polynomial, that doesn't change at all because I would be distributing a positive 1. So that's not going to change any of these values. In my second polynomial, this I have to distribute by negative 1. What I find happens is if people just try to subtract things without actually distributing the negative 1, they tend to make silly sign errors. This takes a lot of that error out. So now I'm going to multiply everything. Negative 1 times 5 gives me negative 5x squared. Negative 1 times negative 6x gives me a positive 6x. And a negative 1 times a positive 1 gives me a negative 1. Okay, then I get to start combining like terms. So I have my squared. So I have this 2x squared and a negative 5x squared. So 2 minus 5 leaves me with negative 3x squared. Then I look at my x's. I've got a negative 7x, a positive 6x, negative 7 plus 6 gives me a negative 1x or negative x. You might see it that way as well. Lastly, I have my constants, negative 8 and a negative 1. So negative 8 minus 1 leaves me with a negative 9. Okay, there's no other like terms here. I have two terms that have x's, but one has a squared, one does not. I cannot combine them any further. So that would be my final answer, negative 3x squared minus x minus 9. This is also written in standard form for us already, so we don't have to rearrange it. Standard form, remember, is when we go from our highest exponent down to the lowest exponent, or in this case, our constant. Okay, so I hope that this answered some of the questions that you guys had after going through that ed puzzle, and then there'll be a follow-up assignment with us. Okay, let me know if you guys have any questions. I'm available to either meet or you can send me an email or a message. Okay, hope this was helpful, guys. Bye.